All right, let's dive in. Today we're going to talk about something that's basically the memory for almost every modern AI you interact with, vector databases. But hold on a second. Why does AI even need a special kind of brain? I mean, we've had powerful databases for decades, right? Why can't AI just use the ones we've already got? Well, it all comes down to how they search for stuff. Think about a normal database. It's a master of exact matches. You ask for John, and boom, it finds John. Super simple, right? But AI has to think differently. It needs to understand meaning and context. So when you ask it about machine learning, you want it to be smart enough to also find stuff about neural networks or deep learning, even if those exact words aren't in your query. It's all about searching for the concept, the vibe, not just the keyword. And that right there, that's what leads us to what's called the high dimension problem. It's the reason your old trusty database just can't keep up with this new world of AI. Okay, so here's the thing. You can technically store these complex AI thoughts, these things are called embeddings, which are just a bunch of numbers, in a regular database like PostgreSQL. I mean, this query you see here, that's real SQL to do exactly that. So yeah, putting the data in, not the problem. The real challenge is getting that data back out in a way that's actually fast. And that search, oh, it is brutally, painfully inefficient. We're talking about something called O of N complexity. Now, what does that mean in plain English? It means that to find what you're looking for, the database has to check every single item, one by one. Seriously. Imagine going to a library to find a book about dragons, and instead of using the card catalog, you have to read the first page of every single book in the entire library. It's insane. It just doesn't scale. So the bottom line is, our traditional databases just weren't built for this kind of work. They have no idea how to properly index this high-dimensional data. They suffer from this wild thing called the curse of dimensionality, which is a fancy way of saying that when you have hundreds of dimensions, everything starts to look equally far away from everything else, and the whole idea of finding the nearest thing just breaks down. The way they access memory, the way they're built, it's just not optimized for the kind of math AI runs on. At scale, they just choke. Okay, so what's the fix? How do we solve this? Well, we have to completely change how we think. We have to start thinking in similarities. We have to search by meaning, not just by exact keyword matches. And that is where vector databases finally enter the picture. These things are purpose-built for one job and one job only, finding similarity. Their entire design from the ground up is engineered to store, index, and query these crazy complex vectors by finding what's close to your query and to do it at absolutely blistering speeds. It is the perfect tool for a very specific, and these days, a very important job. So you're probably wondering, how in the world do they do it? How can these databases sift through millions or even billions of items in milliseconds? Well, there's a trick, a kind of secret sauce, if you will, and it's a technique called ANN, which stands for Approximate Nearest Neighbor Search. Now, this is where it gets really, really interesting. It's all about a trade-off. On the one hand, you've got your traditional exact search. It's slow as molasses, but it's perfect. It gives you 100% recall, meaning it will find the absolute best match, guaranteed. But then you have ANN, and ANN is lightning fast. Why? Because it only checks a tiny, tiny fraction of all the vectors. Now here's the catch, and it's a small one. You might sacrifice a tiny bit of accuracy. You might get, say, 99% recall instead of 100%. But for 1,000 times speed up, yeah, that's a trade-off pretty much everyone is willing to make. And this chart just lays it out perfectly. Look at this. On a dataset with just 1 million vectors, an exact search has to do 1 million calculations. Makes sense, right? One for each. But an ANN search? It might only do 1,000 calculations. You're doing 1,000th of the work to get an answer that is, for all practical purposes, just as good. This is what makes things like real-time AI search even possible. So how does this ANN magic actually work? Well, the most popular algorithm out there is called HNSW, and this quote just explains the whole idea perfectly. Think about it. If you're trying to find a specific person in a huge city, you don't go and knock on every single door, right? No way. You call a friend who knows a friend who lives in the right neighborhood. You navigate a social network. HNSW does the exact same thing, but for data. The way this algorithm works is honestly brilliant. It creates this multi-layered graph that acts just like a city map, with super fast highways on top and smaller local streets on the bottom. So when your search query comes in, it first jumps on a highway entry point. This lets it make these huge leaps across the data to get into the right general neighborhood super quickly. Then, once it's close, it drops down to the more detailed local street layers to do a much smaller, much more precise search to find the final answer. It's just an incredibly smart and efficient way to navigate through a massive amount of data. Okay, so the concept is obviously super powerful, but what about the real world? How do you actually use this stuff? Let's meet the players. We'll do a quick tour of your main options out there in the vector database world. You can pretty much group them into 4 main buckets. First, you've got the managed, zero-ops guys like Pinecone. This is for when you're in production and you just want it to work without fussing over servers. Then there's the open source, dev-friendly stuff like Chroma, which is just fantastic if you're prototyping or just learning the ropes. For the hardcore researchers who want maximum control over every little detail, you've got libraries like Phase from Meta. And finally, if your team is already living and breathing PostgreSQL, you can just use an extension like PG Vector to keep everything under one roof. All right, so with all those options, how on earth do you choose the right one for your project? Don't worry, here's a super simple framework to help you decide. All right, this is your actionable takeaway. Just follow the questions, it's that easy. First step, are you just starting out, prototyping, or maybe just learning? If yes, stop right there. Use Chroma. It is the absolute easiest way to get your feet wet. Okay, next question. Are you ready for production and you want absolutely zero operational burden? You don't want to manage servers? Then a managed service like Pinecone is going to be your best friend. But what if you're already deeply invested in a PostgreSQL setup and want to stay there? Easy. Just start with the PG Vector extension. And finally, if you get to a point where you need more advanced features, like hybrid search, that's where you combine old-school keyword search with this new vector search to get the best of both worlds, then it's time to explore the really powerful options like Weaviate or Qdrant. You know, at the end of the day, it really all boils down to one thing. Your AI's memory is only as good as its recall. It's all about its ability to find the right piece of information at the exact right time. So now that you know about the incredible speed and scale that these databases unlock, the only question left is, what are you going to build with them?